Okay, this question deals with arithmetic and manipulating fractions. So arithmetic and fractions. So a quick review on manipulating converting fractions. A fraction is a ratio. It has a numerator and a denominator. So a real common one that we live with all the time, 1/2. That just means 1 out of 2. It's also a probability. We've talked about if you had 2 marbles in a bag, one red, one blue, and you pulled out, what's the odds of taking out a red one by complete chance? And it's the total number of outcomes, possible outcomes on the denominator, the outcomes you're looking for, the desired outcomes in the numerator. So it's 1/2. This fraction it's representative of a lot of things. It's also equivalent to if you had, let's say, 10 million marbles in a bag and you removed 5 million of them, that is still 1/2. You can reduce this fraction down to 1/2. It's the equivalent of it. So let's look at converting. I put these two up here. If you were asked to add these two fractions, 1/3 and 3/9, you need to find what's called a common denominator in order to add them, because 1/3 is not on the same measure as 1/9. So you can't just add those two across and add those two across and get 2/12, which would be 1/6. It doesn't work that way. If you have 1 of 3 and you want to add 1/9, you have to create a common denominator. And sometimes, like here, you will have denominators that are similar already. You can see that you can either model down the 9 or you can model up the 3. Since we have, I put 1/9. Over here I had 3/9. Let's do 3/9. That'll make it a little bit easier. So we could do either one. 1/3 plus, to make this 9 into a 3, we would have to divide the 9 by 3. So whatever you do to the top and bottom, the numerator and denominator, if you do the same thing to both, it doesn't affect the value of the fraction. So if you divide 3 by 3 and 9 by 3, this fraction becomes 3 divided by 3 is 1, 9 divided by 3 is 3. So now we have 1/3 plus 1/3, and we can just add straight across. If you had a pie and you wanted to divide it up according to these two fractions, you would have this first fraction dividing it up into thirds, something like that. So let's say that this is our 1/3 pie. But then you have this fraction here that says 3/9. In order to accommodate that, we would have to divide, if we didn't reconvert this 3/9 into a fraction with the same denominator, we would then have to look at what does 3/9 equate to in our pie that's divided into thirds. To do that, we would need to divide each of these third sections into thirds again. I've already used this one. So now there's 9, which was our denominator here, and 3 of those, 1, 2, 3, make up this fraction. So 3/9 for this fraction and 1/3 for this fraction. We have This is our 1/3, and this is our 3/9. So you can see all that's left is this third right here that's unaccounted for. That means that the 3/9 took up this third. It's the same as 1/3. And then this one was 1/3. So if we added those together, we have 1/3 and 1/3 equals 2/3. That's if you added these two together. And that's really easy to see in this setting. But what if you had this? So now we're asked to take a pie, and it's divided into eighths. So there's 4. 1, 2, 3, 4. We divide each of those in half to get our eighths. And we have 5 of them. So there's 1, 2, 3, 4, 5. So now this is our 5/8. And then we're asked to add 2/3 to 5/8. Well, how do we do that when we've already divided it into eighths, and now we've got to divide it into thirds like we did over here? That's a completely different number set, a completely different way of dividing it. It's the same way as if you had a number line, and here's 0, and here's 1, and we divide it in half, and then we divide it in half again. So now these are fourths. This is 1/4, this is 2/4, and this is 3/4. But then we divide it again in half. Now this is 1/8. This 1/4 is the same as 2/8. This is 3/8. This is 4/8. And there's 5/8. Oops, 8. 6/8 is the same as 3/4, and 7/8, and then our 1. And then we're asked, well, now we need to add 2/3. Well, this number line is in these halves and quarters and eighths. How do we add on 2/3? 2/3 would be, it's a real number. That might be 1/3. There's 2/3. So this is a third, that is a third, and that is a third. It's a totally legitimate way of looking at how to divide this number line, but it's in a different, it's in a different quantity, this was 2/3, and this would be 3/3, which is the same as 1. So it's in a different denomination, a different way of looking at it. It's legitimate, but you can't mesh the two together yet. So what do you do when you have two things that are numbering it in a different denomination, like 5/8 plus 2/3? That's when we convert these denominators into a common denominator. You've probably heard of LCD, lowest common denominator. It doesn't have to be the lowest to do this. Oftentimes it's easier. The lowest one that you use can be easier because it's smaller numbers. And one way to get there is you just multiply the two together. If you multiply the two together, you know that the result will be common between them because you multiplied them together. But there may be a lower one than that, or there may not be. In this case, there isn't. You start with the highest one, the bigger number, 8, and if you double that, it's 16, but 3 is not a factor of 16. The next one is just 3 times 8, so that became the way to find a common denominator, and it is the lowest common denominator here. So 24. How did we get 24 with this fraction? It was 5/8, and then we multiply the top and bottom by 3, which is just 1. 3 over 3 is 1. Anything multiplied by 1 is just itself, so it's not changing the value of it, but it's putting it into a denomination that will be consistent with both fractions. So now we have 15 24ths, which is the same as 5/8. We've just multiplied top and bottom by 3. And then for the second fraction, this 2/3 right here, 2/3 multiplied by 8 over 8. 8 over 8 is just 1, so all we're doing is multiplying 2/3 by 1. It's not going to change the value of the fraction, just like we did up here. 1/2 is the same as 5 million over 10 million. Well, 2/3 is the same as 2 times 8 is 16 over 24. But now we have two fractions with a common denominator. Now we've taken the pi, and instead of dividing it in 8s and then trying to layer on top of that thirds, it didn't work. We've divided the pi into 24ths. So if we started, there's halves, now it's in quarters. Now we would have to divide each of these quarters into 6. So that'd be 6 plus 6 plus 6 plus 6 is 24. And I'm not going to actually do it, but that's what you would do. You divide each of those into 6. Now you have 6, 6, 6, 6. That's 24. And we can add up our 15 of those. So if we took this to there, that would be 12 of the 24s. That's 1/2. And then we would take 3 more to there. Now that is this would be our 15 24s. And then we're going to add to that 16 more 24s. So we've used 15 of them. Now, coming all the way back around, there's 9 left in this full pi. So we're taking all 9 of those, and we still have 7 more to reach 16. So we took 9, we've got to get 7 more. This would be 6, and 1 more. So that's where we end up. We get a full number, a full 24, and then 7 more. So our total will end up being 24 plus 7 over 24. Hopefully you can see that. And it's the same, 24 plus 7 equals 31 over 24. And you can see our 15 that we started with here and our 16 there. 15, let's put it down here, 15 24ths plus 16 24ths equals 15 plus 16 is 31 24ths. And that is the same as, I'll put it over here to end, 1 and a remainder of 7 24ths. So you can see how it's important to be able to convert these fractions, and in order to add them in a denomination that is equivalent, so that you can compare them instead of having things that are denominated in different number systems. I forgot to go over decimals real quickly. Decimals are actually pretty easy. Whatever fraction you're given, so we've worked with a number of different fractions, all you do is divide the denominator into the numerator. So one of the fractions that we dealt with was 5 over 8. What is that as a decimal? You just divide, because this line means division. You just divide. It's the same as 5 divided by 8. And that would equal 0.625. That's the decimal value of 5 over 8. And being able to convert fractions into decimals can be very helpful, because oftentimes decimals are easier to work with than fractions, because all you're really doing when you do this, dividing 8 into 5, is you're converting it into a common system so that you can add things up. You have these disparate systems, 5 over 8, 2/3, 1/8, 1/10, 6/57. How do you add those instead of having to create common denominators like we did through all of this? By dividing the denominator into the numerator, you are creating each fraction, converting it into a common system, a decimal-based system that makes it much easier to deal with. Then you can add, multiply, subtract fractions much easier. So that's all that you're doing when you work with decimals, is converting the fraction into a system that is equivalent, and then you can work with them. So let's answer the question.